Module 2, I'm going to do these in 2 separate videos just to make it a little easier for me. So this is an investment that pays $50,000 every other year forever. The first payment occurs 1 year from today, and the discount rate is 9% compounded daily. What's the value today if the first payment occurs? What is the value of this? And then he changes the question for the second part to say, what's the value today if the first payment occurs 4 years from today? Assume 365 days in a year. Okay, so the first thing that we're going to do is the same thing that we do in all these problems. We are going to convert the APR from 0.09 to the effective daily rate. And since I've done this problem twice now, I'm going to go ahead and write in effective biannual rate and effective annual rate, and I'm going to wrap this text too. Okay, the effective daily rate is going to be that divided by 365, and we are going to forget that APR ever existed because now we have the effective annual rate. The effective biannual rate is the 2-year rate, so it's going to be 1 plus this to the power of 365 times 2. We'll need this because the payments occur every 2 years, and what we want to do is make our timeline and make the payments occur every other year. All right, the effective annual rate is this 1 plus the effective daily rate to the power of 365. We will need this because of the discounting and how things work. Okay. So, $50,000 starting 1 year from today. 0, 1, 2, 3, 4, 5. And we get I'm going to call this years. I'm going to call this biannual time. Okay. You can't really discount it because you can't go on forever. So this is going to continue. This is going to continue until we're all old and gray. And actually, like if you really wanted to, you could copy it down just to get the effect. Let me fix this. Etc. Okay, but this won't help us all that much. The other way is to think of it in biannual years. So the way that I would think about it is to call this time 0, call this time 1, 2, 3, 4, 5, and so on. Remember when we have an annuity, we're standing here, and we have some cash flow C that happens in each time period going forward. And we can do C over R to get the present value. Okay, we can do the exact same thing here. If we are standing in this time period, the present value of all of these cash flows, except for the first one, because we're standing here in time 0, is going to give us the present value of this annuity. So the way to do this problem is to think of these as a separate cash flow. I'm going to move them over and get the present value of this. So our cash flow is 50,000, and our R is going to be the effective biannual minus 1 because we want to get it in percent terms, not the 1 point whatever. And I'm going to black out all of these numbers now because this is how much someone would pay at time 0 for all of the cash flows in here. It is the present value of the perpetuity of a $50,000 annuity that pays a $50,000 perpetuity that pays every other year. So now that we have these, and we're standing in time 0 in biannual years, we want to make it go back in time to time 0 years. So this is a cash flow that you get while you're standing at time 0 in biannual years, And this is the present value of the, oops, the present value of the perpetuity. This, let's see, I'll make it a color. This is the present value of, not the present value, it'd be the present value if you're standing in time 0, but now we have to get it back to time 1. Well, the way that we do that is just that divided by the effective annual rate, divided by the effective annual rate to the power of, well, it's only 1, which will be the same number. This is going to be your present value if you were standing in time 1. There's 0 cash flows here. So we summed these, it was 300,000. We got the present value of all the cash flows, and then the NPV, which is a little bit arbitrary, oops, is just going to be the sum of all these. And since we only have one cash flow, it's $277,000. And notice that that is the answer that he comes up with here, 277 and change, 437. Yep. So this is the answer. I'm going to do the next one as a separate video just so you can not have to watch so much.